Question 1. From the perspective of system diagnosis, Mr. Thompson observes that the air conditioning unit's compressor cycles on and off frequently despite normal thermostat settings. He suspects short cycling issue. What is the most likely underlying cause Mr. Thompson should investigate first? A. Incorrect refrigerant charge causing low pressure in the system. B. Faulty thermostat wiring leading to intermittent signal loss. C. Oversized compressor relative to the cooling load capacity. D. Blocked or dirty condenser coils reducing heat rejection efficiency. Answer. Correct answer. C. Explanation. Short cycling commonly occurs when the compressor capacity is oversized compared to the cooling load, causing the system to reach the desired temperature too quickly and shut off prematurely. This wastes energy and increases wear. While low refrigerant charge and dirty condenser coils affect performance, they typically cause longer run times or compressor strain, not frequent cycling. Faulty thermostat wiring could cause an operation but is less likely than load mismatch in this scenario. Proper sizing is fundamental for system reliability and efficiency. Question 2. Considering the evidence in psychrometrics Dias is adjusting an HVAC system to improve indoor comfort in a humid climate. She notices high indoor relative humidity despite adequate cooling. What approach should she prioritize to effectively reduce indoor humidity levels? A. Increasing the airflow rate through the evaporator coil to lower the dew point temperature. B. Lowering the supply air temperature to enhance moisture condensation on the coil. C. Adding a dedicated dehumidification system or reheat cycle to remove latent heat. D. Installing a larger evaporator coil to increase sensible heat removal capacity. Answer. Correct answer. D. Explanation. Increasing sensible cooling capacity by enlarging the evaporator coil can lower the air temperature more effectively, increasing moisture condensation and reducing relative humidity. Simply increasing airflow reduces core contact time and can actually decrease dehumidification. Adding dedicated dehumidification or reheat cycles is often costly and complex, typically a last resort. Lowering supply air temperature without sufficient coil surface area may cause frost and system issues. Coil sizing must balance sensible and latent loads. Question 3. In the context of EPA regulations, Mr. Patel is performing maintenance on an older HVAC system that uses R22 refrigerant. He wants to ensure compliance while upgrading the system. What is the best course of action for Mr. Patel to take? A. Continue using R22 as long as no refrigerant is vented during servicing. B. Replace all components and retrofit the system for approved alternative refrigerants. C. Recover and recycle existing R22 refrigerant, then convert the system to R134A. D. Replace the system entirely, as R22 is banned from production and use. Answer. Correct answer. B. Explanation. EPA regulations prohibit venting R22 and mandate recovery and recycling. Continuing use without venting is allowed, but retrofitting with approved alternatives is best to ensure environmental compliance and system longevity. Complete replacement is often recommended but not strictly required if retrofit is feasible. Converting to R134A may cause compatibility issues. EPA-approved alternatives like R407 are preferred. Responsible refrigerant management aligns with environmental safety standards. Question 4. With respect to airflow principles, Nguyen notices uneven airflow distribution in a multi-zone duct system, causing some rooms to overcool while others remain warm. Which action should she take to most effectively balance the system? A. Increase the total system static pressure to push more air into all zones. B. Install balancing dampers to regulate airflow independently in each duct branch. C. Add additional supply registers in undercooled rooms to increase airflow. D. Reduce return air openings to increase pressure in the supply ducts. Answer. Correct answer. B. Explanation. Balancing dampers provide precise control of airflow in each branch, allowing adjustment to match the cooling load per zone and improve comfort evenly. Increasing total static pressure may overload fans or create noise without resolving imbalance. Adding registers can exacerbate imbalance without controlling flow rates. Reducing return air openings restricts airflow and can reduce overall system efficiency. Effective duct balancing requires independent flow control per zone. Question 5. Based on the information about control systems, Mr. Kim finds that a contactor coil in a commercial unit frequently burns out shortly after replacement. After thorough inspection, what underlying issue should he suspect and address first? A. Incorrect coil voltage rating causing excessive current draw. B. Poor mechanical alignment causing physical coil damage. C. Frequent short cycling caused by thermostat or control logic issues. D. Contactor contacts worn out, resulting in coil overheating. Answer. Correct answer. D. Explanation. Worn or pitted contacts increase resistance, leading to coil voltage drops and overheating, which causes coil burnout. Checking coil voltage is important, but contact wear is a common root cause. Poor mechanical alignment rarely damages coils electrically. Short cycling stresses the coil, but contact deterioration must be corrected to prevent recurring coil failures. Proper contactor maintenance extends coil life and system reliability. Question 6. During the process of troubleshooting, Lopez encounters an HVAC system where the evaporator coil frost buildup occurs rapidly after a recent service. She confirms correct refrigerant charge and airflow. What should be her next diagnostic step? A. Inspect the expansion valve for improper superheat settings or blockage. B. Increase the blower speed to warm the coil and prevent frost. C. Add more refrigerant to compensate for possible leaks. D. Replace the filter to ensure proper air filtration and reduce frost. Answer. Correct answer. C. Explanation. Rapid frost buildup despite normal charge and airflow often indicates low refrigerant charge due to leaks, causing the coil temperature to drop below freezing. Adding refrigerant after confirming leaks is necessary to restore balance. Expansion valve issues cause improper refrigerant metering but would more commonly cause flooding or starvation symptoms. Increasing blower speed may help airflow but won't fix underlying low charge. Filter replacement aids airflow but unlikely sole cause of rapid frost. Question 7. Given the circumstances of an installation scenario, Mr. Singh must decide on the proper location to place a pressure transducer in a refrigeration system to measure accurate compressor discharge pressure without interference. Where should he place the transducer? A. Directly at the compressor discharge port. B. On the liquid line before the metering device. C. In the condenser discharge line after the condenser. D. On the suction line entering the compressor. Answer. Correct answer. A. Explanation. Accurate compressor discharge pressure readings require placement as close as possible to the compressor discharge port to avoid pressure losses or fluctuations caused by tubing bends, valves, or condenser effects. The liquid line and condenser discharge line measure different pressures and do not reflect compressor discharge. Suction line placement measures low side pressure, not discharge. Proper sensor placement is crucial for system diagnostics and control accuracy. Question 8. The fundamental question is, Mr. Allen is assessing an HVAC system's energy efficiency and notices excessive power consumption by the condenser fan motor, which is PSC type. What might explain this inefficiency and what corrective action should be taken? A. Incorrect capacitor sizing causing the motor to run at low torque and high current. B. Worn bearings increasing mechanical load, requiring motor replacement. C. Blocked airflow at the condenser causing the motor to overwork. D. Use of shaded pole motor instead of PSC motor for the condenser fan. Answer. Correct answer. D. Explanation. Shaded pole motors are less efficient than PSC motors for condenser fans due to lower starting torque and higher power consumption. Using the correct PSC motor improves efficiency and reduces energy use. Capacitor sizing and bearing condition affect motor performance but are less common root causes. Blocked airflow causes heat buildup, but the primary inefficiency comes from motor type. Selecting appropriate technology aligns with energy efficiency standards. Question 9. When evaluating the merits of various refrigerant types, Foster is tasked with recommending a refrigerant for a high-efficiency residential air conditioning system with environmental concerns in mind. Which refrigerant characteristics should she prioritize? A. Low ozone depletion potential, OP, and low global warming potential to be high flammability rating for better thermodynamic efficiency. C. Compatibility with existing R22 system oils without retrofit. D. Maximum achievable cooling capacity regardless of environmental impact. Answer. Correct answer. B. Explanation. While low OPD were important, the question focuses on a high-efficiency system with environmental concerns, and prioritizing low flammability refrigerants ensures safe, widespread adoption. Highly flammable refrigerants pose safety risks that limit practical use despite efficiency gains. Compatibility with old oils is secondary when retrofits are considered. Cooling capacity alone should not. Environmental and safety factors. Balancing performance, safety, and environment is critical. Question 10. Throughout the course of maintenance, Mr. Ramirez observes that a multi-speed blow-up motor's low-speed winding is drawing abnormally high current while the high-speed winding operates normally. What is the most plausible explanation and solution? A. The motor capacitor is failing and needs replacement. B. The low-speed winding is short to ground requiring motor rewind or replacement. C. The blower wheel is unbalanced causing mechanical overload on the low-speed winding. D. Incorrect wiring connection causing improper current draw on the low-speed winding. Answer. Correct answer. A. Explanation. A failing motor capacitor often causes low-speed windings to draw high current due to improper phase shift and reduced torque. Short to ground usually causes tripping or grounding faults, not just high current. Mechanical imbalance affects both speeds equally and typically results in noise and vibration rather than current difference. Incorrect wiring is possible but less common and easier to verify. Capacitor health is for multi-speed motor operation. Question 11. Based on the information about thermodynamics, Garcia notices that the heat transfer rate in a copper pipe carrying refrigerant is significantly less than expected, even though the temperature difference between the refrigerant and pipe wall is sufficient. What is the most probable cause of reduced heat transfer? A. Fouling or scaling inside the pipe, reducing conduction efficiency. B. Incorrect refrigerant type with low thermal conductivity. C. High velocity flow causing turbulent heat transfer. D. Excessive insulation around the pipe preventing heat loss. Answer. Correct answer. D. Explanation. Excessive or improperly applied insulation limits heat loss to the environment, reducing the overall heat transfer rate even with sufficient temperature difference. Fouling or scaling inside the pipe mainly affects fluid flow and pressure drop rather than conduction through pipe walls. The refrigerant type influences capacity but generally not heat transfer rate directly at this scale. High velocity typically increases transfer due to turbulence, not decrease it. Question 12. During the process of refrigerant leak detection, Mr. Collins uses an electronic leak detector near a system charged with R400 TINA. The detector does not indicate any leaks despite noticeable pressure drops in the system. What should Mr. Collins suspect is the primary issue? A. The leak detector is not calibrated for R400 TINA sensitivity. B. The pressure gauge used is faulty and reading incorrectly. C. The leak is located in an inaccessible area not tested by the detector. D. The system has a slow, non-pressurized leak undetectable by electronic sensors. Answer. Correct answer. A. Explanation. Leak detectors must be properly calibrated or designed for the refrigerant type. Some electronic detectors are less sensitive or incompatible with newer refrigerants like R400 TINA, causing false negatives. Pressure gauges might be faulty but less likely if pressure drops are consistent. Inaccessible leaks require physical inspection, but detectors typically sense refrigerant concentration nearby. Slow leaks be detected over time. Detector calibration is a primary factor. Question 13. Which of the following best explains why Mr. Ahmed should not use a shaded pole motor for a large commercial condenser fan despite its low cost and simplicity? A. Shaded pole motors have low starting torque, making them unsuitable for high-load applications. B. Shaded pole motors consume more power than PSC motors in small residential units. C. Shaded pole motors are incompatible with high-voltage power supplies. D. Shaded pole motors require complex control circuits, increasing installation costs. Answer. Correct answer. C. Explanation. Shaded pole motors are typically designed for low-power, single-phase applications and may not handle higher voltages reliably or safely in large commercial settings. Their low starting torque is a factor but not the primary limitation for commercial fans. They are simpler and do not require complex controls, and power consumption comparison is application dependent. Voltage compatibility and motor sizing Dictate appropriate motor choice. Question 14. Under the assumption that a building's duct system is improperly sized, causing high static pressure, what is the most likely impact on the HVAC system's overall performance? A. Increased airflow throughout the system leading to overcooling. B. Reduced blower, motor efficiency and potential premature failure. C. Enhanced filtration efficiency due to higher air velocity. D. Improved heat exchange in coils from increased air velocity. Answer. Correct answer. B. Explanation. High static pressure forces the blower motor to work harder, reducing efficiency and increasing wear, potentially leading to premature failure. Increased airflow is unlikely because high static pressure restricts flow. Filtration efficiency is generally unaffected or worsened by higher velocities, causing filter bypass or damage. Heat exchange improves with proper velocity, but excessive pressure usually reduces flow and efficiency. Question 15. According to recent studies, Mr. Wilson needs to determine the best approach to minimize moisture intrusion in a commercial building's ventilation system. Which design principle should he prioritize? A. Ensuring positive building pressurization relative to outside air. B. Maximizing fresh air intake to dilute indoor contaminants. C. Minimizing return air duct leakage into conditioned spaces. D. Using high-efficiency particulate air HEPA filters in ventilation. Answer. Correct answer. A. Explanation. Positive building pressurization prevents moist outside air from infiltrating through leaks and cracks, reducing moisture intrusion and potential mold growth. Maximizing fresh air intake without pressurization can introduce moisture. Minimizing return air duct leakage is important for efficiency but less directly related to moisture intrusion. HEPA filters improve air quality but do not address moisture infiltration. Question 16. In a modern context of HVAC safety procedures, Evans is about to service a system containing a known toxic refrigerant. What is the most critical safety protocol she should follow before starting work? A. Verify that the refrigerant cylinder is properly labeled and secured. B. Ensure the work area is well ventilated and use appropriate personal protective equipment (PPE). C. Confirm the refrigerant type matches system documentation. D. Perform a pressure test on the system to detect leaks. Answer. Correct answer. B. Explanation. When handling toxic refrigerants, ensuring ventilation and wearing proper PPE, respirators, gloves, goggles is essential to protect health from inhalation or exposure. Label verification and leak tests are important but secondary to personal safety. Matching refrigerant type is operationally critical but does not replace hazard mitigation through ventilation and PPE. Safety protocols prioritize health first. Question 17. Taking into account the principles of system charging, Mr. Brooks finds the superheat on a controlled system is unusually high during a load test. What should be his immediate troubleshooting focus? A. Checking for undercharged refrigerant causing insufficient evaporator pressure. B. Inspecting the condenser coil for dirt reducing heat rejection. C. Verifying the expansion valve for possible stock open condition. D. Increasing the blower speed to enhance airflow over the evaporator. Answer. Correct answer. B. Explanation. High superheat with TXV typically indicates insufficient refrigerant flow or heat rejection problems causing the coil to run hotter. Dirty condenser coils reduce heat rejection, increasing pressures upstream and affecting superheat. Undercharge causes low pressures and low superheat. A stuck-open valve lowers superheat, not increases. Blower speed affects sensible heat transfer but is less likely immediate cause. Question 18. In light of recent developments in energy efficiency, Mr. Clark is evaluating variable speed motor drives for an HVAC system. What is the primary advantage of installing a variable frequency drive (VFD) on the system's compressor motor? A. Lower initial installation cost compared to fixed speed motors. B. Ability to precisely control motor speed to match cooling load demand. C. Reduced complexity in motor wiring and control systems. D. Increased starting torque for rapid system startup. Answer. Correct answer. C. Explanation. VFDs allow precise motor speed control, matching compressor output to load, reducing energy consumption and wear. However, initial costs are higher and wear and control Complexity increases. Variable speed reduces starting current, but increased starting torque is not typical. The complexity of EFD systems is generally greater than fixed speed motors. Question 19. When analyzing the merits of various duct materials for installation, Murphy considers the effects of thermal conductivity and airflow resistance. Which statement best describes the trade-offs involved? A. Metal ducts offer low airflow resistance but high thermal conductivity leading to energy losses. B. Flexible ducts have low thermal conductivity but high leakage rates reducing system efficiency. C. Fiberglass ducts have high airflow resistance but excellent sound attenuation. D. All duct materials have negligible impact on airflow or heat loss if properly sealed. Answer. Correct answer A. Explanation. Metal ducts provide smooth interior surfaces minimizing airflow resistance but conduct heat easily, causing energy loss unless insulated. Flexible ducts typically have higher airflow resistance and leakage potential. Fiberglass ducts are good for sound control, but their resistance varies. No duct material is perfectly sealed or thermally neutral. Material choice affects performance significantly. Question 20. Considering the evidence in electrical systems, Mr. Lopez notices that a compressor motor's overload protector frequently trips even though current readings are within normal limits. What could explain this behavior? A. The overload protector is incorrectly sized and too sensitive. B. Voltage imbalance causing excessive heating despite normal current. C. Loose electrical connections increasing resistance and heat. D. Failing motor capacitor affecting startup current. Answer. Correct answer A. Explanation. Overload protectors must match motor specifications. If too sensitive or incorrectly sized, they trip unnecessarily. Voltage imbalance typically shows as high current or reduced performance, but normal current readings here reduce its likelihood. Loose connections cause heat, but usually manifest in voltage drops or arcing faults. Motor capacitor issues affect startup current, not steady-state overload. Question 21. When faced with a system showing unusually high superheat and low suction pressure, Mr. Reynolds suspects a metering device issue. What would be the most logical step for him to confirm the problem? A. Inspect the expansion valve for blockage or sticking in the closed position. B. Increase the refrigerant charge to reduce superheat levels. C. Check for airflow restrictions over the evaporator coil. D. Verify compressor operation for proper displacement. Answer. Correct answer C. Explanation. High superheat with low suction pressure can result from restricted airflow over the evaporator coil, causing insufficient heat absorption and excessive refrigerant vapor superheating, while a stuck expansion valve can cause low superheat is less likely to cause these combined symptoms. Increasing refrigerant without proper diagnosis risks overcharging. Compressor issues may cause other symptoms but do not directly. High superheat with low suction pressure. Question 22. In the context of control systems, HRConquer is troubleshooting a multi-stage thermostat that fails to advance to the second stage heating. After verifying wiring and power, what is the most probable cause? A. Faulty stage 2 relay or contactor core preventing activation. B. Thermostat programming set to single stage operation only. C. Improper voltage supplied to the thermostat terminals. D. Defective temperature sensor not triggering stage 2. Answer. Correct answer D. Explanation. Multi-stage thermostats rely on accurate temperature sensors to initiate higher stages. A defective sensor can prevent progression despite proper wiring and power, while relay faults or incorrect programming are possible. Sensor issues are a common underlying cause. Improper voltage usually results in complete thermostat failure. Correct sensor operation is crucial for stage control. Question 23. Given the circumstances of a system installed in a corrosive coastal environment, Mr. Wallace must recommend a suitable condenser coil material. Which option best balances durability and performance? A. Copper coils with protective coatings to resist salt corrosion. B. Aluminum coils due to lower cost and ease of replacement. C. Bare galvanized steel coils for maximum corrosion resistance. D. Stainless steel coils despite higher initial cost. Answer. Correct answer B. Explanation. Aluminum coils are commonly used in coastal environments because they resist salt corrosion better than copper and galvanized steel, and their low cost and lighter weight facilitate maintenance. Copper with coatings can protect, but coatings wear over time. Galvanized steel has limited corrosion resistance in salt air. Stainless steel offers excellent corrosion resistance but at prohibitive cost for most HVAC applications. Question 24. Taking into account safety procedures Huang is preparing to service a system suspected of refrigerant leak and traces of oil contamination. What immediate step must she take before opening the refrigeration circuit? A. Vent the system refrigerant outdoors to prevent exposure. B. Use appropriate personal protective equipment and evacuate air with proper recovery equipment. C. Check for electrical continuity in the system components. D. Increase ventilation in the workspace without using PPE. Answer. Correct answer. A. Explanation. Venting refrigerant outdoors is strictly prohibited by EPA regulations and safety best practices due to environmental harm and health risks. The correct immediate action is to wear EPE and recover refrigerant using certified equipment to prevent exposure and contamination. Electrical checks are secondary to ensuring safe refrigerant handling. Simply increasing ventilation without PPE is unsafe. Question 25. With respect to psychrometrics, O'Connor notices that the wet bulb temperature is constant while dry bulb temperature varies significantly in space. What does this indicate about the air conditions? A. The moisture content of the air is changing while enthalpy remains constant. B. The air humidity ratio remains stable despite temperature fluctuations. C. The space is experiencing condensation and high relative humidity. D. There is change in sensible heat only with no latent heat transfer. Answer. Correct answer. C. Explanation. Constant wet bulb temperature with fluctuating dry bulb temperature often indicates air or near saturation with condensation likely. Wet bulb temperature is influenced by moisture content. Stable values near saturation suggest high relative humidity and latent heat processes. Moisture content is unlikely changing if wet bulb is constant. Sensible heat changes would reflect in dry bulb variations. Latent heat transfer is present near saturation. Question 26. When analyzing electrical circuits, Sister Sharma observes a motor circuit with a sudden voltage drop when starting, causing the motor not to start. What is the likely cause of this issue? A. Excessive resistance in the start winding or capacitor failure. B. Incorrect wiring configuration of the motor leads. C. Overvoltage on the power supply causing protective trips. D. The motor is oversized for the application load. Answer. Correct answer. D. Explanation. An oversized motor may require higher starting current, causing voltage drops and insufficient starting torque. Excessive resistance or capacitor failure affects start windings, but typically result in slow or failed starts without voltage drop. Incorrect wiring causes functional failure, but not voltage drop in supply. Overvoltage trips are protective and not associated with starting voltage drops. Question 27. For the purpose of system charging, Taylor finds that the subcooling measured on a high-efficiency heat pump is below manufacturer specifications. What corrective measure should she prioritize? A. Add refrigerant to increase the liquid line pressure and subcooling. B. Decrease airflow over the condenser coil to raise subcooling. C. Adjust the expansion valve to increase superheat. D. Replace the compressor due to internal leakage. Answer. Correct answer. C. Explanation. Low subcooling usually indicates insufficient refrigerant in the condenser, possibly due to overfeeding by the expansion valve or system issues. Adjusting the expansion valve can correct flow and increase subcooling. Adding refrigerant is not ideal without diagnosing system balance. Decreasing airflow is unsafe and reduces efficiency. Compressor replacement is drastic and not first line. Question 20. Within the framework of air distribution and duct systems, Mr. Johnson is tasked with designing a duct layout to minimize pressure losses. Which design principle should he apply? A. Use long, straight ducts with minimal bends in gradual transitions. B. Increase duct diameter uniformly regardless of branch lengths. C. Install multiple sharp 90-degree bends to improve airflow. D. Use flexible ducting exclusively to simplify layout. Answer. Correct answer. A. Explanation. Long, straight ducts with gradual transitions minimize turbulence and static pressure losses. Increasing diameter without considering airflow demand can increase cost and space but does not reduce losses if duct design is poor. Sharp bends increase turbulence and pressure loss. Flexible ducts add resistance and potential leakage, suitable only for short runs. Question 29. How might one explain the benefit of implementing demand-controlled ventilation (DCV) in commercial HVAC systems? A. DCV reduces ventilation rates during low occupancy to save energy. B. DCV increases air changes per hour to improve indoor air quality constantly. C. DCV eliminates the need for filtration systems. D. DCV controls refrigerant charge dynamically to optimize cooling. Answer. Correct answer. A. Explanation. Demand-controlled ventilation adjusts fresh air intake based on occupancy or co-levels, reducing unnecessary ventilation and saving energy while maintaining comfort. Increasing air changes constantly wastes energy. DCV does not replace filtration, and it controls ventilation rates, not refrigerant charge. Question 30. Is illustrated by a scenario. Easton Ewan finds that a system's blower motor is overheating and shutting down frequently after recent maintenance. The system used PSC motor. What is the most likely cause? A. Incorrect capacitor size reducing starting torque and causing overload. B. Blocked return air filters restricting airflow and causing overheating. C. Worn motor bearings increasing mechanical resistance. D. Incorrect wiring causing continuous full-speed operation. Answer. Correct answer. B. Explanation. Restricted airflow from blocked filters increases static pressure and motor load, causing overheating and shutdown. Capacitor issues reduce torque but less commonly cause overheating. Bearing wear causes noise and load but usually gradual. Wiring issues cause operational faults but not specifically overheating from airflow restriction.